Okay, so in this video we are going to be looking at the mensuration of the circle. Okay, we're going to be looking at the mensuration of the circle. What are some things that we need to understand about a circle? Okay, now a circle has this shape, okay, has this shape, and it always has a center, just right here, an origin. Okay, it always has a center, an origin there. Yes, it always has a center, an origin. Okay, now this total length, this total distance around this circle, this total distance is what is referred to as the circumference. Okay, this total distance is what is going to be referred to as the circumference. And as usual, this is our origin O. Okay, this is going to be our origin O. Now notice the distance from the origin, the center, to the circumference. This distance is what is referred to as the radius. And one thing that you need to know is that the radius in any given circle is constant. So which means that the distance from this center O touching this circumference will also be the radius. Even the distance from this center up to that point there, this will also still be termed as the what? As the radius. Okay? As long as you're starting from your point O, reaching to that total distance, or to that circumference, that is what is going to be referred to as the radius. If you sum the radius values together, that is r plus r, if you sum the radius values together, what you're just going to have is your diameter. So this means that your diameter can be expressed as 2 times the radius. If you add this radius value with that radius value, what you're going to have here is the diameter. Okay, what you're going to have there is the diameter. So the diameter is 2 times the radius. If your radius is the subject of the formula, then this can also be written as radius is just the half of the diameter, which you can just say as radius is equal to diameter divided by 2. So know this formula 1, know this formula 2. So your diameter is twice the radius, and your radius is just half of your diameter, which is just the same as diameter divided by 2. Okay, so having known this, it's important that you also need to know something that we like to call the segment. You need to know what a segment is. A segment is just the area bound. Segment is the area bound by a chord and an arc. Okay, and an arc. So area bound by a chord and an arc. So the diameter is an example of a chord, a straight line that is stretching from one point of the circumference to the other. Let me put another circle like this. So imagine this is your point O. This is your diameter. Let me write that properly. This is your diameter. It always passes through the center. This can be an example of a chord. A chord is any line that stretches from one point of the circumference to the other. The diameter here is a special chord. Why is it special? Because it always passes through the center of the circle. I'll focus on this chord though. Let us imagine this is point A and this is point B. This entire section here is what is going to be referred to as your segment, because it is being bound by this chord and this arc. This part of the circumference is what is referred to as an arc. So an arc is just simply a part or a portion of the circumference. Yes, don't forget that. An arc is just simply the portion or part of the circumference. So, this is an introduction. You really need to know these things. So, area bound by a chord and an arc. So an arc is just simply this portion of the circumference. And arcs can come into many different categories. There are major arcs, there are minor arcs, but we still determine them in the same way. So, apart from knowing what a segment is, you also need to know what a sector is. A sector is just an area bound. Area bound by two radii and an arc. So, a sector is an area bound by two radii and an arc. An example, if we look at this circle, I'll also put another one here because I want to show some people a difference here. I want to show you guys a difference here. Let me also put another one. I want to outline a particular difference here. Let us assume this part was, okay, it's fine. Let's just go on with it like this. So this is your center O. This is also your center O. Remember, this is your radius value. This is also your radius value. This is your radius value. This is your radius value. Remember, we're saying that the area which is bound by two radii and an arc is what is actually termed as the what? As the sector. So, what you need to know now is this. If I was only looking for this part, of the circle, if I was only looking for this part of the circle, this one here, this part here is going to be termed as a sector. Why? Because it is being bound, it is being formed from two radii. One radius value here, another radius value there, and this arc. And this is the angle of the sector. So think of the sector as a portion of a circle. So this is going to be the angle representing this sector. Let us also try to look on this other one. If this is the part that we really wanted, notice that this one is being bound by this radius, and also this arc that we're seeing here. If this is the part that we're looking for, this one will also be given as a sector, and the angle that is going to be associated with it is this one here. So a sector can come in this way with the angle representing it, or it can also come in that way. Of course, the common way in which a sector is brought is in this way. But don't forget, a sector is just an area bound by two radii and an arc, which means that a sector can also be brought in this way, though uncommon. But you just need to know this. Now, having said that, having given ourselves an introduction to what a segment is and what a sector is, what therefore do we also need to know? What formulas should we familiarize ourselves with anytime we're talking about the mensuration of the circle? We have seen that the diameter is just twice the radius and the radius is just half the diameter. That's the other way of saying it. But if we start with a circle, the area formula of a circle is going to be given by pi r squared, the area formula. So let's start with the circle before I come to its derivatives, like the segment and the sector. These are derivatives of a circle. So the area formula of a sector, or rather of a circle, is A for the area is equal to pi r squared. The perimeter of a circle is known as its circumference. Don't forget that. The perimeter of a circle is known as its circumference. The perimeter of a circle is just 2 pi r. So it's just basically getting these two and then you drop it here. So this is just going to be 2 pi r. These are the formulas that you need to know concerning a circle. So I'll call this equation 3 and I'll call this equation 4 or formula 4 if you want. So A is equal to pi r squared, that's the area formula of a circle. The perimeter or circumference formula of a circle is just 2 pi r. If you differentiate the area with respect to the radius, you're going to have your circumference, which is 2 pi r in that way. What if you're talking about the sector? What if you're talking about the sector? Now, before you know something about a sector, let me write it like this. If you're dealing with a sector, I'll start with its area. Remember, this is your radius value. This is also your radius value. The angle representing the sector is here, which is just going to be theta, right? If you're talking about the area formula of a sector, the area formula of a sector is just going to be theta out of 360 multiplied by pi r squared. Theta over 360 multiplied by pi r squared. Why? Because that angle is just simply a portion, a part of this whole angle of revolution here, which is 360 degrees. This is going to be theta over 360 because this is just a portion, a part of this entire angle of revolution, which is your 360 degrees. So it's going to be theta over 360 times pi r squared. If you're talking about its perimeter, the perimeter of a sector is going to be given in this way. The perimeter of a sector is going to be given in this way. This is going to be, remember, it's the total distance around a given shape. So it's going to be this radius value plus this radius value plus this arc length. So O, A, B. There is this arc length. It's an arc, remember? So we definitely need to know how to calculate its length. So if I add these two radius values together, this is just going to be 2r. Okay, 2r. Plus the arc length. The arc length, remember, we said that the arc is just a portion of the circumference. It's a part of the circumference. And we saw that the circumference or perimeter of a circle is given by 2 pi r. So the arc length, which in this case I'm going to be referring to as AB, the arc length is going to be given by 3, or rather theta over 360 times 2 pi r. That's going to be the arc length formula. Theta over 360 times 2 pi r. So r plus 360, theta over 360 times 2 pi r. So theta over 360 times 2 pi r. You can leave it in that way, or you can simplify it further. How? 2 here is 1. 2 into 360, the answer is just going to be 180. So what you're just going to have here will be 2r plus, and then if we just multiply it directly here, what we're just going to have will be pi r theta over 180. And if you choose to evaluate this more, this is just going to be over 180. Definitely 1 into 180 is just 180 times the 2r, you're going to have 360r. 360r plus pi r theta. Yes. So this is your evaluated formula for the perimeter of a sector. You can choose to use this. That is 360r plus pi r theta. Of course, you can factorize it so that you have your r from the outside. I think, let me just write it. And then this is going to be 360 plus pi theta over 180. If you want, you can go for this one. Let me put this first one. If you want, you can go with 2r plus theta over 360 times 2 pi r. Or if you want, you can just say P is equal to r 360 plus pi theta over 180. So there you go. That's your area formula of a sector. This one here. This is your perimeter formula of a sector, though this one is not evaluated. If you evaluate it, you're going to have this. So whether you pick this or you pick that, you're still going to arrive at your answer. But there are times where questions can be, let me just say, complicated at some points. Okay, questions can be complicated at some points where, say, you have been given this. Well, this is a poor drawing. We put it in this way. And then you can be given another sector in a sector. And then maybe this is your O, your A, your B, your C, and your D. And then a question can be given for you to determine the area of the shaded region. And there is the shaded region. You can be asked to determine the area of this shaded region. If you're determining the area of this shaded region, remember there are two sectors here. That's the angle. There is this one, the small one, and then there is this big one. So if you're trying to determine the area or even the perimeter of this shaded region, what we normally do is that we find the perimeter of this small one, and then we find the perimeter of this bigger one, and then we just subtract those two values together. The same concept can also be applied on the area. We can find the area of this small one, and then we find the area of this bigger one, and then we just subtract the values. You will still have your area value of this shaded region. And then once that happens, you're going to get your full marks. If it's given in this way, you can be asked to determine the area of this shaded region. Imagine this is a sector. This is all. And not forgetting, this can be your 90 degrees here. And definitely this is going to be a radius value. No, the radius value is this one that is written up here. The radius value is just going to be this guy and this guy. You can also be asked to determine the area of this shaded region. Now, provided that this length has been given, which I can just call L, the length of this chord has been given. If you're trying to determine the perimeter of this segment, the perimeter of this segment will just be L plus theta over 360 times 2 pi r. Because remember, this segment is being made up of this chord and this arc, which is here. The length of the chord plus the length of the arc length. If you're trying to determine the area, provided maybe say there is an angle that has been given here. If you're trying to determine the area of this shaded region, what we normally do is that we determine the area of the circle, not the circle, the triangle, and also the area of the sector, and then we subtract the values. Let me show it simply like this. The area of the segment will be equal to, this is going to be the area of sector minus the area of the triangle. The area of the entire sector minus the area of this triangle that we have here. Now, in a case whereby you're trying to determine the area of the triangle, the area of the triangle under a sector is going to be given by half r squared sine theta. Half r squared sine theta. This is a special kind of a triangle. So it's going to be half r squared sine theta, the one that is just right there. That's the formula that you're going to use to determine the area of the triangle. The area of the triangle. And of course, we have already seen the area formula of a sector. This is theta over 360 times pi r squared. It will still work. And once you do that, you can just subtract your two values, and you're going to have your final answer in that way. If the height has been given, if it is known, and the length of the chord has been given, in a case whereby you forget half r squared sine theta for the area of a triangle, you can just use this basic one that we all know, which is half BH, where your length of the chord is going to be your base, and h is going to be your height. So this is how they may try to complicate up things. But it all starts up with the foundation. Once you know the area formula of a circle, the perimeter or circumference of the circle, the area of a sector, the perimeter of a sector, even if they try to complicate it up in this way, you will still know what to do. So the concept here is to just grab these formulas. So for the area formula of a triangle here, you can use half r squared sine theta, or if you want, you can just go directly to use a is equal to half bh, where b is just the base, and the base here is the length of this chord, and then your height value, provided that it has also been given, you just go directly like that. So this is what we can say regarding the mensuration of a circle, and also its derivatives, like the sector and the segment. Thank you very much.